For the last couple of sections in our text, Chapter 5, you're going to look at how to solve systems of equations with 3 equations and 3 unknowns. There are a couple of new features introduced. One is algebraic, but the other uses some technology. And that's what this particular video is about, is this technology feature. A calculator can be used to solve a systems of equations using what's called the reduced row echelon form, or rref, feature within the calculator. It's programmed to form these row operations that you will experience from reading the text and doing problems algebraically, and it continues to do those operations until all the unknowns are isolating, making the solutions clear. This feature also uses a matrix. First of all, you've got to make sure that your system is in standard form, meaning that all of the variables are to the left, preferably in that order, the same, well, they need to be in the same order, in this case, X, Y, Z, and all of the constants are to the right of the equal sign. Any place that you do not see a variable, you can think of it as an understood plus 0 y, for instance in this case where there's a missing y. Next, you're going to construct what's called a matrix with 3 rows and 4 columns that includes the coefficients and constants, but not the variables. This is called the augmented matrix. We insert zeros for missing terms. The dotted line you're getting ready to see represents this equal sign. This is what the matrix looks like for the previous example. So take a moment and see, where did these ones, 1, 1, -1, -3, come from? The values in this first row come from this first equation. They are the coefficients 1, 1, -1, and the constant -3. It's like that for each row within the matrix. The matrix looks very similar to the determinant if you think back to what you saw from the previous section, and you will continue to use determinants in some different examples that involve 3 equations and 3 unknowns. So look forward to that, okay? But it does have that similar kind of table type feature to it where it has rows and columns. The notation is just slightly different in that we typically use these square brackets to denote matrices, whereas the determinant had just these like vertical lines on both sides. So next, we use that rref feature to convert this matrix into its reduced row echelon form, which essentially means it goes through all those algebraic processes for you that you learned about earlier in section 5.5. And in that form, the solutions are going to be in the last column. Let me show you what it looks like first, and then next I want to show you how to do this in a Desmos matrix calculator. So what I've done here is I've just opened up a new window in my web browser. I'm going to desmos.com/matrix. The first thing I need to do is I need to create a new matrix. So let's select that one. I want to make sure that it has 3 rows because it had 3 equations and 4 columns. If you happen to go one too many, it's no big deal. You can also delete a column. So it's pretty forgiving that way until you know that you have the look that you want. I'm writing the coefficients for the first equation here, and I can press the tab key to move from one cell, if you want to call it, or element, technically is what we call it for matrices, to the next. And that very last element of the matrix should be the constant. I can continue to press tab and I can get down to the next row. Notice that the 0 means that there is no y term. And then the last row looks like this. And I can just press enter or press this return key on my screen. That green dash line, notice it does not appear here, but that is just for your benefit to know that separates the coefficients from the constants. Next, we're going to bring up this what's called rref, or reduced row echelon feature, and it is right here on your screen. It is that commonly used for matrices. This matrix was given a name when we created it, and it was named A. So I'm going to select A here, and what I'm seeing is the reduced row echelon form of matrix A. What this tells me in the last column is the solution to the system of 3 equations and 3 unknowns. Specifically, it means that x is -1, y is 1, and z is 3. Notice that it's in that order, that almost standard order, because we first wrote the system in standard form. So that's how you can use a calculator, specifically the Desmos matrix calculator, to help you with this reduced row echelon form, and also check over your algebraic techniques as well.